The lumen is the SI-derived unit of luminous flux, a measure of the total quantity of visible light emitted by a source. Luminous flux differs from power in that radiant flux includes all electromagnetic waves emitted, while luminous flux is weighted according to a model of the human eye's sensitivity to various wavelengths. Lumens are related to lux in that 1 lux is 1 lumen per square meter. The lumen is defined in relation to the candela as 1 lumen equals 1 candela senior. A full sphere has a solid angle of 4 pi steradians. So a light source that uniformly radiates 1 candela in all directions has a total luminous flux of 1 candela times 4 pi senior equals 4 pi CD senior 12.57 lumens. Explanation: if a light source emits 1 candela of luminous intensity uniformly across a solid angle of 1 steradian, the total luminous flux emitted into that angle is 1 lumen. Alternatively, an isotropic 1 candela light source emits a total luminous flux of exactly 4 pi lumens. If the source were partially covered by an ideal absorbing hemisphere, that system would radiate half as much luminous flux, only 2 pi lumens. The luminous intensity would still be 1 candela in those directions that are not obscured. The lumen can be thought of casually as a measure of the total amount of visible light in some defined beam or angle, or emitted from some source. The number of candelas or lumens from a source also depends on its spectrum, via the nominal response of the human eye as represented in the luminosity function. The difference between the units lumen and lux is that the lux takes into account the area over which the luminous flux is spread. A flux of 1000 lumens, concentrated into an area of 1 square meter, lights up that square meter with an illuminance of 1000 lux. The same 1000 lumens, spread out over 10 square meters, produces a dimmer illuminance of only 100 lux. Mathematically, 1 lux equals 1 lumen per square meter. A source radiating a power of 1 watt of light in the color for which the eye is most efficient has luminous flux of 683 lumens. So a lumen represents at least 1/683 watts of visible light power, depending on the spectral distribution. Lighting. Lamps used for lighting are commonly labeled with their light output in lumens. In many jurisdictions this is required by law. A 23W compact fluorescent lamp emits about 1500 to 1600 lumens. Many compact fluorescent lamps and other alternative light sources are labeled as being equivalent to an incandescent bulb with a specific wattage. Below is a table that shows typical luminous flux for common incandescent bulbs and their equivalents. On September 1, 2010, European Union legislation came into force mandating that lighting equipment must be labeled primarily in terms of luminous flux instead of electric power. This change is a result of the EU's Eco-Design Directive for energy-using products. For example, according to the European Union standard, an energy-efficient bulb that claims to be the equivalent of a 60W tungsten bulb must have a minimum light output of 700 to 750 lumens. Projector output. Ansi lumens. The light output of projectors is typically measured in lumens. A standardized procedure for testing projectors has been established by the American National Standards Institute, which involves averaging together several measurements taken at different positions. For marketing purposes, the luminous flux of projectors that have been tested according to this procedure may be quoted in Ansi lumens, to distinguish them from those tested by other methods. Ansi lumen measurements are in general more accurate than the other measurement techniques used in the projector industry. This allows projectors to be more easily compared on the basis of their brightness specifications. The method for measuring Ansi lumens is defined in the IT 7.215 document, which was created in 1992. First, the projector is set up to display an image in a room at a temperature of 25 degrees Celsius. The brightness and contrast of the projector are adjusted so that on a full white field, It is possible to distinguish between a 5% screen area block of 95% peak white, and two identically sized 100% and 90% peak white boxes at the center of the white field. The light output is then measured on a full white field at 9 specific locations around the screen and averaged. This average is then multiplied by the screen area to give the brightness of the projector in Ansi lumens. Peak lumens is a measure of light output normally used with court video projectors. The testing uses a test pattern, typically at either 10 and 20% of the image area is white at the center of the screen, the rest is black. The light output is measured just in this center area. Limitations with court video projectors result in producing greater brightness when just a fraction of the image content is at peak brightness. For example, the Sony VPH-G70Q court video projector produces 1200p lumens but just 200 Ansi lumens. Color light output brightness measures the total amount of light projected in lumens. The color brightness specification color light output measures red, green, and blue each on a 9-point grid, using the same approach as that used to measure brightness. Experts advise projector buyers to make certain that white light output and color light output are equal for optimum viewing experiences. SI photometry units. SI photometry quantities V, T, E, carat standards. Organizations recommend that photometric quantities be denoted with a suffix V to avoid confusion with radiometric or photon quantities. For example, USA standard letter symbols for illuminating engineering USAS Z7.1-1967, white 10.18-1967. Carat ABC alternative symbols sometimes seen. W for luminous energy, P or F for luminous flux, and Rho or K for luminous efficacy. Carat ABC, J. Here is the symbol for the dimension of luminous intensity, not the symbol for the unit joules.